What's the most you could lose simply playing the pass line at these tables? To find out, I'll simulate thousands of sessions playing the minimum at $5, $10, $15, and $25 tables. This will show us the typical outcomes that we might expect and help us understand what the best and worst outcomes could be. My name is Matt, and welcome to Dice Data. I've simulated 10,000 sessions. On average, the $5 shooter wagered $126, increasing to $630 at the $25 table. The average amount won is just under $2 for the $5 table and just under $9 for the $25 table. Of course, the average amount won is negative due to the house edge. We can actually calculate the house edge by dividing the average win by the average wagered. This ranges around the theoretical value of 1.42%, allowing for some of the natural variation of the game. The thing is, I hate looking at statistics in this way. Absolutely none of the sessions would result in exactly this loss. Instead, I prefer to look at the median values. These are the values where half the sessions are higher and half are lower. You can see here that the medians wagered are nice round numbers compared to the table minimums. This gives more of a real feel as to what can actually happen at the table. The median win, or should I say loss, is one betting unit. $5 for the $5 table, and so on. And we can see that the median house edge is 4%. So again, half the players experience a house edge of greater than 4%, and the other half less than 4%. Now I'll plot all the outcomes on a single chart. I'll put the number of betting units won or lost on the x-axis. For example, 5 betting units for the $5 table would be 5 times 5 or $25. The $10 table would be 5 times 10 or $50. So on. The bar heights are the frequency of outcomes. A higher bar means this is a more likely outcome. Here I've highlighted the median of 1 unit lost. I'll also highlight the 25th percentile on either side. This shows us that 25% of sessions won 4 betting units or more, while the worst 25% of sessions lost 5 units or more. So half the time, playing this relatively boring strategy, you'll end up between winning 3 or losing 4 betting units. Here are the edges. 1% of the time you may win more than 13 units or lose more than 10 units. So really, 98 times out of 100, you'll be between these two values. One thing that's interesting is that this distribution is not perfectly symmetrical. The tail on the right side is a little longer, meaning at the extremes you could win more than you might lose. This is an artifact of the game because you're more likely to win on the come-out roll, and each shooter can miss the point at most once when they 7 out. I hope you found this analysis interesting. Future videos will examine more complicated and frankly more interesting strategies. Let me know in the comments which strategies you would like me to simulate. And as always, please play responsibly.